is our pulley systems question 2. So we have a slightly more complicated looking system here. Particles of mass 4 kilograms and 2 kilograms are attached by 2 light inextensible strings which pass over 2 smooth pulleys to a 1 kilogram sitting in the smooth table as shown. System is released from rest. Find the acceleration of the particles and the tensions in both strings. Remember in our last example we had two things, we had a 2 kilogram and 5 kilogram, and we did F equals ma for each of those. We're going to do F equals ma for this one, and this one. Because this is smooth, there's nothing holding it in place. This is a smooth table, so once it's released from rest, because this is 4 and this is 2, the whole thing is going to go this way here. I hope that makes sense. So let's stick our accelerations on first of all, and we'll see how we go. So our acceleration is going to be going that way. Our acceleration is going to be going that way. And our acceleration is going to be going that way. What forces are acting on this? We have 4G. And we have T1. What's going to be acting on this? That's T1. Because those are different masses, the tension here is a different string to this one, so the tension might be here. So I'm calling this T1, and then this is going to be T2. T2, and then 2G. So I've put on all the relevant forces, I suppose. So what about the 4 kilogram one? This is going up, this is going down. What about the 1 kilogram one? There's this one, this one. This, incidentally, there's also a 1G acting this way, and there's also an R acting this way. We don't need to deal with those. And then we have a T2 here, and we have a 2G. So we're going to do F equals ma for each of our 3 bodies and see what we end up with. So first of all, our 4 kilogram one, this is our one here, F equals ma, so it's 4a, and our T, so it's 4g, take away T1. For a 1 kilogram particle, F equals ma, slightly different one this one, but all we have, so you have A just here, and then what way is it going? It's going this way, so the T1's the bigger one, so T1 take away T2 equals A. And then for a 2 kilogram force, so a 2 kilogram particle, F equals ma. Mass is 2, acceleration is A, so we have 2a, and this one's going this way, so it's T2 take away 2g, and we end up with that. There are loads of different ways of kind of solving these kind of 3 equations, 3 unknowns. The way I'm going to do it is I'm going to get T1 on its own here and sub it into this, T2 on its own here and sub it into this, and that'll give me the accelerations, and then I can go on and work out the tensions. So T1, if I rearrange this, T1 equals 4g minus 4a, I'm calling that equation 1. Equation 2, T1 take away T2 equals A, nothing changed. Here I'm getting the T2 on its own, 2A plus 2G, I'm calling that equation 3. And what am I doing? I'm subbing 1 and 3 into 2. So T1, 4G minus 4A. Take away T2, take away 2A, take away 2G. Careful with that there, hopefully that makes sense. That all equals A. So this is just equation 2 written out. This is my T1, this is my take away T2, and I have that. First of all, the G's. I have a 2G here. 4A and a minus, that's a minus 6A. Take it over the other side, you end up with a 7A. So we're nearly there. We have A equals 2 7th G. Hope you see where that comes from. That's ms to minus 2. You guys will like to see what that is as a number, and we end up with 2.8 ms to the minus 2. We now need to use that to work out our 2 tensions. It's actually easier to sub it into these 2 versions rather than these 2 versions. It just makes our sum slightly easier. So let's go for this here. T1 equals 4 times 9.8, take away 4 times 2.8, Surely that's quite easy. 9.8 take away 2.8 gives me 7, so it's going to be 28 newtons. T2 equals 2 upon 9.8 plus 2 upon 2.8. T2. Oh, you can't even see that. Apologies. Hopefully that makes sense. There's my T1 there. 4 upon A minus 4 upon my, sorry, 4G. Take away 4A. And we have that. And then 2.98. So just put it in the calculator here. And I end up then with 25.2 newtons. Hopefully that all makes sense. But again, with these things, you are worried about what forces are acting on each of the particles. This one, and this one. And you do F equals M for that. Why are we doing F equals MA? Because it's acceleration taking place. And I do that every time.